Hello. Oh. So I'm getting a bit hot. Right. Hello there. Don't be a dick. Sorry, I'm talking to a single. What? How's that wobbly? No way. I thought to do an interesting video covering an article by Physics.org. Anyway, it's a physics site, okay? And it's about time travel. This is curves in space-time violate the Heisenberg's uncertainty principle. Just give me a second. Oh, for fuck's sake. Why is that wobbly? Right. Behave yourself. Right. Which is kind of like to do with paradoxes and stuff like that. You might have heard about it in Avengers Endgame, which I might bring up about, which I may mention, but I might mention it now. This article covers the variables and stuff, and the way, because of time travel works. I'll get to that in a minute. But yeah, the whole idea is Tony Stark, mentioned Heisenberg uncertainty, and he basically worked it out so that when they travelled, they could find their way back to their point, because as I suppose, like you could say in the Flash film, it's like spaghetti. So, but we'll get into that in a minute. Curves of space-time violate Heisenberg's uncertainty principle. But yeah, so basically Heisenberg, what I'm getting at is, because I mentioned some, go for some bits myself, what I know something. But it's like I said, you're probably first, if you haven't heard of it through, school or anything like that, it's like it was mentioned in Endgame, because he was like, oh, the problem is you've got this Heisenberg uncertainty factors, and it's like, and then he spent all night and he had that thing mapped out on the computer, and he's like, oh, I solved it, yeah? You got around that problem, yeah? But this kind of fixes that in a way. So anyway, that diagram there, I'll put a link to the article so you can look at the diagrams. A close time-like curve in which P2 is chronologically respecting system and P1 is a time travel system that can okay. Like I said, I'll put a link in I got a link to the article. If an object travelling through space-time can loop back in time in a certain way, then its trajectory can allow a pair of its components to be measured with perfect accuracy, violating Heisenberg's uncertainty principle. This new finding involves a particular trajectory called an open time-like curve, OTC, which is a special case of a closed time-like curve, CTC, a theoretical concept that has been previously provoked controversy because it raises the possibility of travelling backwards in time. So yeah, it's also kind of like, I'll probably get explained further, but so far my impression of that, because I did have a quick scan for this. But the thing is, there's also there's an interesting thing, right, where you've seen it. Actually, the Flash covers it, but again, the reason why Endgame still works is because he worked through the Heisenberg uncertainty, if that makes sense. He came up with that path. It's one of the ingenious ways that the TARDIS works, the computer, the TARDIS, because it's a Time Lord machine, so it can count, when he says timey-wimey, wibbly-wobbly, it literally is timey-wimey, it's like it's a spaghetti mess. And what the computer, the TARDIS, does, it actually calculates and works out where your origin point, where you need to go, it actually maps it out accurate on a quantum level. So it's a really impressive piece of machinery. And that's one incredible way of doing it, is if you had a TARDIS. But there's like an example, it might mention this, but it's like, for example, when the way Michio Kaku put it, I think it was Michio Kaku or someone who's show. They were talking with Neil deGrasse Tyson about time travel, and it's the way it's kind of like the Flash. You know when you noticed, in the Flash film, even in Endgame, it's kind of like alternate. You're going back to an alternate timeline, so it's kind of like if you were to go back in time, if you haven't got a machine that's like the TARDIS, you're literally in essence hitting like a multiverse of different timelines. In a way, or put simply, you're sort of tapping into a multiverse in a way. So basically, they were saying if you went back in time to save Abraham Lincoln, the problem is you'll be saving someone else's Abraham Lincoln, and it's like if you look at the Flash as well, the idea is obviously a pebble. The effects don't just go forward; they go backwards. But the thing is, because we seem to think it just branches. Oh. Which I know it does, but it's not just a simple split branch. It's like spaghetti. It's all over the place. It's like a multiverse of different timelines, realities. It's like, it's like, so, for example, the changes he did, because he caused that ripple in time, Bruce Wayne ended up getting born years earlier, hence why when he saw Bruce Wayne in that timeline, he was older. You know what I mean? It was Michael Keaton's Batman, yeah? It's like, so like, I need a blackboard, but, so you got a line here, instead of just branching off like that, it goes across like that. And it might mention fixed points in time, I can't remember, but also the thing is like say in terms of Marvel Universe, you have a fixed point in time, an event which is universal throughout the multiverse, called a nexus point, which you can't check. That's hard to change. I mean, usually, to be fair, these events are big. You know what I mean? But the whole idea, but the thing is, again, the problem, as highlighted in Endgame, for example, if I wanted to remove someone evil from history, if I removed them and was able to get back to where I was, I'm removing someone else's evil dictator, yeah? So the only way you could actually find out how things unfolded, say, for example, you went back in time and removed Hitler, you'd have to stay where you were and live that branched reality to see what happens. Because if you go back to because the thing is also, another way of looking at it, as way as the Endgame looked at it, is you may think you're going back in time, but no matter which direction you're going on your world line, on this, don't go dark on me, on this world line, you're still going forward. So you're not actually going backwards in time, you're going forward. To everyone else who's not going with you, you're going back in time, but you're actually going forward. So in either direction, you're still going forward, if that makes sense. So, yeah, see, like you're going back. So when you come back on yourself, and it's still, it's like it branches off, but obviously it gets more complicated. It's like a spaghetti, but you're going back on that thing. So as you go back, that change you've caused has caused a branch off, so it doesn't affect the present, if it makes sense, which also puts the idea of when people go, oh, there's a theory that some aliens are time travelers. The problem with that is if these aliens are time travelers, then they'll be aware of what I'm telling you. So if they're from the future trying to save the Earth, well, our future may not be the same as theirs. And not only that, if they come back here and help us improve or stop a so-called disaster, it won't make a difference. If they went back to where they came from, the Earth would still be a mess. It wouldn't work, if that makes sense. It's like, so in a way, it gets the whole principle of like the Heisenberg uncertainty is also that thing where it's kind of like the grandfather paradox. Whereas what quantum physics and string theory is what's saying now is you could go back in time and erase yourself, but you'll be killing yourself in an alternate reality or multiverse, yeah? So yeah. Pardon me. So one of these, indigestion. Pardon me. Right. So the thing is, to be fair, there's nothing that says going forward in time is easy, but there's nothing in quantum mechanics that says you can't. It's just the risks, or you know what I mean, the different what could happen. You know what I mean? According to Heisenberg's uncertainty principle, measurements of any pair of variables must have at least minimum amount of error. The most well-known example of a pair of variables is position and momentum. But the principle applies to any two variables that have mathematical relationship which makes them conjugate variables. The uncertainty principle is thought to be an inherent property of quantum systems due to their wave-particle duality, rather than any observational limitations. Although previous studies have found that CTC models can theoretically violate the uncertainty principle, nobody knew that this could happen for the special case of an OTC. Now, physicists Jacques Pignard, Tim Ralph and Casey Myers at the University of Queensland, Australia, have theoretically shown that OTCs can allow scientists to measure a pair of conjugate variables of a quantum state to an arbitrary degree of accuracy forbidden by the uncertainty principle. The finding can have implications for quantum gravity and change the way scientists view quantum uncertainty. There is some speculation that the Heisenberg uncertainty principle might be different in a future theory of quantum gravity, Pignard told phys.org. However, most of these studies suggest that quantum gravity will introduce more uncertainty. Our model suggests the complete opposite, that a theory of quantum gravity might actually remove the uncertainty of quantum mechanics. This perfect measurement ability arises from the nature of OTC trajectories. As the physicists explain, OTCs are the simplest and most normal type of CTCs, whereas CTCs form closed loops in time that allow systems to affect events in our own past. OTCs form open loops in time and do not allow systems to interact with previous versions of themselves. These interaction-free OTCs overcome some of the paradoxes associated with time travel, such as the grandfather paradox, in which a time traveller kills their own grandfather, preventing their own existence. Again, it's like that whole thing of, like I said, if you go back in time to try and save Abraham Lincoln, you're saving someone else's Abraham Lincoln, not yours. So if you came back to the future and went, oh, did I do it? You know, and check the history books, he'll still be dead. The actual the clever thing, is, I suppose quantum gravity is like Ant-Man, that delves in that realm anyway, but it is quite clever though to by simple the ripple effects, the butterfly effects. It's kind of like the idea of oh yeah, but if we bring back, so it's kind of like, also it's because people go, yeah, but if they took the time stones from the past, because this is the thing, you see, this is what confuses a lot of people. Because, for example, with Avengers Endgame, right, they go back in time and take all the stones, right? A lot of people going, well, hang on, if they went back in time and did that, then that means Doctor Strange, on the prime timeline, the main timeline that say we live in, right? Why didn't that cause ripple effect? Why couldn't Doctor Strange then defeat Dormammu and all this sort of stuff? But that's because you've technically gone to a different, someone else's reality, effectively. But the clever thing about Endgame is the fact that they've gone, well, you're to prevent them screwing up their reality, because Tony Stark mapped it like the way he did. Steve Rogers could then go back in time, return the stones which then doesn't fuck up that doesn't mess up that reality, and then he goes off into some other reality and lives his life with Peggy, and then uses a pin particle to come back. And the reason why he was able to do that is because he still had the equipment they had on the mission. So, he just basically had the readings, coordinates, whatever. He didn't activate it until, when he was old and he passed on the shield at the end of Avengers. So it's really fascinating. But yeah, like I said, it's like, it doesn't matter if you go back and change or try and undo stuff, you're doing it to someone else's reality sort of thing. It's also why there's an uncertainty with you could do it just by travelling near the speed of light to go to the future. But let's just say you wanted to say for example, you had the technology to, effectively you could use the same technology that you used to go back in time to go forward. Say for example, you jumped far enough into the future, that would be still in your lifetime, for example. Yes, so to still be in your lifetime. But the interesting thing is you'd bump into yourself because spaghetti is out both ways, if that makes sense. So also it's that thing of there's a risk of travelling into the future and finding out what happens to you, because it's like, say for example you died in a car crash. It's kind of like that's one of many futures on the spaghetti. You know what I mean? Despite such paradoxes, CTCs in general are compatible with general relativity. However, they are not compatible with quantum mechanics. One way to make them compatible is to extend quantum mechanics in a way that resolves the paradoxical aspects of CTCs. An example of such an extension is the Deutsch model. You probably heard that in Avengers. Thing is, I didn't just hear about this for Avengers, but I just love the fact that science and geek stuff mashes together in films and shit. You know what I mean? Such as the Deutsch model, which makes the mathematics of quantum mechanics non-linear, allowing for CTCs. Oh my god, sorry, I'm having a nerdgasm in my brain. Previously, scientists have shown that... I love this sort of shit. Previously, scientists have shown that this non-linear leads to some unusual properties, such as the possibility to build a super quantum computer that can quickly solve some complex problems called MP-complete problems. A task that would take trillions of years using today's computers. The only problem with that, though, is when it comes to AI, it's like, do you want it to have AI as well? Because if you give that quantum computer AI, then it's going to be smarter than you no matter what. You're handing it. Like, it's scary. But, because people go, it won't happen. This will probably never happen in our lifetime. And rightfully so that people say, AI won't happen in a lifetime. But it's not that that's the problem. Because someone along the line will give this quantum computer AI. And because it can, it has that level of the way it works, it's just going to learn very quickly. You won't need to teach anything. And it will quantify concepts that are beyond your mind. You know what I mean? The multiverse, time travel. If it works in our favour, you could effectively build a TARDIS. Because that's what a TARDIS is, as a quantum computer. Right. So, it's fascinating. In a new study, the physicists have shown that the Deutsch model's nonlinear mathematics also applies to OTCs, where there is no interaction between the past and the present, provided that entanglement exists between the time-travelling system and external system. To reach this conclusion, the physicists calculated what happens when quantum states travel through a quantum optics circuit that contains an OTC. That's why Ant-Man's fucking astounding, because, you know what I mean? How the quantum realm and all that sort of shit does this kind of really cool stuff, you know what I mean? In this theoretical situation, two quantum states are squeezed into orthodiagonal directions. After the states cycle through the circuit several times, the scientists found that they could measure the orthogonal components with arbitrary accuracy. The interesting as well, I think what they're saying as well, and I could be wrong, but is this will enable us to map it. Like this is like helps us get to, in a way, it will help us get to the answer that Tony Stark did in that when he's thinking about shit. You know what I mean? Another interesting feature of the OTCs is that they resemble time dilation in general relativity, in which two clocks measure different times under different gravitational conditions. In a similar way, OTCs create a time difference between two initial synchronized trajectories. Pardon me. As the scientists explain, this resemblance means that an experimenter observing an OTC system and a time dilation system might not be able to tell whether the time difference was due to the gravitational curvature of general relativity or to the trajectory of an OTC. Oh, fucking hell. This finding suggests that the modelling gravitational time dilation as an OTC effect could have implications for a theory of quantum gravity. Deutsch's model describes the strange quantum effects that we might see in the presence of CTCs within a future theory of quantum gravity, Pignard said. Forgive me if I'm pronouncing it wrong. However, if there are no CTCs in the universe, then we would not expect to see the effects, but since the slowing of time due to gravity looks just like the effect of an OTC from the outside, and since OTCs still lead to strange effects, as we have shown, we suggested that these effects might turn up in strong gravitational fields, even without any closed loops in time. If so, then they would allow us to violate the Heisenberg uncertainty principle and clone coherent states of light without needing a full-blown time machine. Fuck it. No, I'm not even reacting to... I've got fucking goosebumps, man. Thing is, people get a bit bummed out because... Don't forget, this stuff may not happen in a lifetime, but that's not the point, man. So the other thing is, well, it's like, it all comes down to, it's that thing. Even though I hate the introduction, opening scene to Enterprise. Partly because it didn't show that all of mankind's endeavours, it's mostly American. It didn't show you could get Gagarin going to space. I think a fan did an edit, which is way better. But it's that naivety of like, it's like, yeah, don't give me false promises. We'll never have Star Trek technology in my lifetime. It really sucks. But then again, there's an irony to this as well, because like Picard said in First Contact, when he's talking to Lily, who built the Phoenix with Zefram Cochrane, from his future perspective as a 24th century person, he envies people of our time who had that thing. He's living in a place where all this stuff's accessible, yeah? Warp speed, time travel, all this stuff is accessible to him. Whereas, even though we may not have that, we have the joys of discovering that. We have the excitement of going, ooh, like I've got here, the goosebumps. You know what I mean? We have that excitement to go, fucking hell, it's possible. We have that Doc Brown moment of like, great Scott! You know what I mean? Of course, the connection... Sorry, why would we ever do this? Alright. Suggest these fix my term for strong gravitational field, blah, blah, blah. Right, so of course the connection between OTCs and gravitational fields is still very speculative and might turn out to be wrong. We hope to flesh out in a more complete theory in future research. Also, just to throw this in, the other thing that makes me laugh as well is scientists, in a way, sometimes hold back science because I can't remember what experiment it was, but NASA, these scientists, accidentally created a micro warp bubble, and there was a lot of naysayers slagging it off. Not naysayers, but these people were just like criticising, oh yeah, it's a lot of good in it. So they didn't see the potential behind the experiment, because the experiment showed, yes, it was a micro one that happened by accident, but that accident told us they actually discovered that you don't need the extravagant amounts of energy that we first believed. You only need half that energy to make a warp drive. And sometimes scientists can hold that back by going, don't give up just yet. Any hint you discover, don't give it up. Don't give up on it. Right? And this is the thing as well, because it also answers questions. Okay, so people say, what happens if aliens are from the future? And they would, if time travel happened, if someone invented time travel, wouldn't we know about it? We'll know, because, like I said before, if they went back in time to change something, that's in a different reality. This one's still chugging along. You know what I mean? It's fascinating stuff. So it's kind of like you wouldn't notice it. The other thing is, if there did, the other thing as well, it's quite funny because it's a simple answer. Well, if by some chance you changed something in the past and it changed this reality, all of us would have no knowledge of it, because whatever is happening now is our reality. We'll have no memory of the differences. Only the traveller would have that know-how. It's also kind of like, I mean, to be fair, even the new Star Trek films did it, because it's like, but everyone's like, well, why wouldn't you have changed the prime timeline then? Well, no, it's as they nickname it, the Kelvin timeline. He created an alternative reality, which is, incidentally, it's pretty cool. Was it Star Trek Online? They had the Kelvin timeline, they had all the Enterprise. I was like, that planet where they saw Abraham Lincoln, and it was like shapeshifters testing them, like made of lava, and it was testing humanity and that sort of thing, or something like that, in the classic series. I went to that planet, and it's like the Enterprise, not the Enterprise G, but the Enterprise F came along, and he's like, I brought some friends, and then Archer's Enterprise, all the Enterprises from all the different timelines turns up, and it's like, oh man, it's so cool. But yeah, that's why you have like it didn't affect the timeline we knew, because it's an alternate reality, like they said on the bridge. Oh, we're in an alternate reality. Hence why Spock said, he did actually ask, because there are some similarities, like when he asked about Khan and stuff, there are some. The thing is, it's like you could get advice, you could ask for advice, etc., but there's no point asking them about the future, because it's a different outcome. It's a different. It just wouldn't work. It wouldn't benefit you, because events have happened differently. They've changed. Because you're now living out a new branch reality, sort of thing. The physicists proposed that testing this possibility by testing the Deutsch model's nonlinear effects could be done with current technology by performing experiments on entangled systems in Earth gravitational field. As the scientists explained, this kind of experiment would serve as an alternative to experimenting with real OTCs, which are rather hard to come by. The circuit itself is easy to build. It's coming up with an OTC that's the problem. Pinyar said it. Strictly speaking, we would require an actual time machine in order to build that circuit, which we obviously don't have. However, if an analogy between OTCs and gravity is correct, then we could make do with just an ordinary gravitational field like the Earth's. In that case, the circuit certainly can be built. There is already a group working on sending entanglement beams of light up to a satellite in orbit. This would then provide an experimental test that could either prove or disprove our claim about gravity behaving the same as an OTC. Oh, I want to see the results. Man. So yeah. Oh my word. Fascinating stuff. But yeah, I'll put a link to the article in the thing below, but man, I love this stuff. I want to share it with you, so my thoughts on it, but yeah. But to be fair, Endgame's right. Correct. It is correct. Things like in terms of what it's saying, but the Flash movie takes it in terms of idea more. I mean, it doesn't even the best way he could come up explaining it, because it's so complicated, is literally it's like a bowl of spaghetti, because your world line goes out like this. Because there's a lot of people find this hard to believe, because the only way this can't, I don't know, how do I explain this? Because in some ways, the only way it can't happen. Oh, hang on, sorry. Sorry to cover up my what's it? But it's like when you think about it, it's like when you make a decision. Yes, say for example, it's a yes or no. So I'm going to do this, or I'm not going to do it. Unless your life's been predestined. Something, I don't know, it's kind of like, I'm not saying this is right, but I'm trying a simple way of saying it. It's kind of like the universe has to compensate for that initial, yeah? Because you've thought of both ways you could go with that. So that there's another idea that your world line, no, there's never one round when I need one. Ah, here we go. Actually, no, I could use that. So imagine your world line straight, right? So at the moment it's one, but your life cone or world lifeline then branches out like that into the future as well as the past, if that makes sense. So it's kind of like I suppose it's like a ripple or what's something like that. But yeah, but anyway, so it's like essentially your world. Fuck's sake. So your world line on a basic level looks like that, but then you make a decision. So not shooting it's down. So we'll just keep it easy. It goes down to 2. So there'll be a reality somewhere of what would happen if you went ahead with a decision, and one where you didn't, depending on your decision. So it's also like, if this is your world line, it's like the whole idea of like Avengers Endgame. So we'll forget about the spaghetti for a moment, because Tony Stark worked out so you don't go all over the fucking place. Even though technically you're not in a prime timeline, you're still in someone else's timeline. Actually, I think what he did, it's kind of like he developed a system where you could count. I think it's not. I think what he did, more to the point, is he worked out a system where you could actually track where you were going. Because all these uncertainties, you would literally be like, see, hang on, if I can do this, look, gets in a mess, look. You'd be dealing with a loads of things, right? Which you may never come back from. So basically, if you go like, that's the main world line. So when you go back in time, as it were, to keep it simple, right? Thing is, I'm not walking, I'm not going back as we think it. You're still going forward, because what you're doing is you're bending your future line, right? That world line, you're bending it going backwards. Yeah? So when you do that bit in the past, you then go back like that. As save a simplification, but anyway. So yeah, so that's how Endgame works. But obviously, the actual, if you don't have a way of charting your course, how to get back and all that, then you get spaghetti. But yeah, it's like the interesting thing is that there's, with quantum mechanics and that, there's this idea that you won't get paradoxes and things like that, because it's kind of like it's like a thing, you want to go back in time. I said, let's change history. Abraham Lincoln was fucking amazing, skip a French. If we saved him, America might have been different. So then you go back in time, It's like there's a film called Pax Romana that it got ditched, but the idea is to get like a unified Earth or a United Nations back in history. So they try and get peace amongst the Roman Empire, like Pax Romana. The thing is, even if you try to do that, it wouldn't work for you, at least, because if you actually did come back to your original point in time. See, that's the difference between Tony Stark and the Flash. I mean, the Flash didn't know what he was doing, you see, because if you remember, if you haven't seen spoilers, by the way, so it was slightly different when he came home. For those who know what you mean, you know what I mean. Different, yeah. And he was like, "What the fuck happened there?" Again, it's because Spaghetti, he came back to a present that was like, because not all realities are such, but there'd be a large number of realities where the past or events would unfold the same. Yeah, so let's keep it down to 2. So even if you came back to the present, if you didn't map it like Tony Stark did, like the Avengers did, you could end up on a different Spaghetti, which looks familiar and exactly, there's not another one of you. It's exactly the same, but there's differences. It's complicated, but But yeah, the reason why that happened, because he didn't know what he was doing. He just fucked about time, thinking he could change it. But hey, with the Endgame thing, it's like so I have to do that because I don't want to hear it, and I haven't got the bee's knees and technologies. I can't edit it all out. But yeah, so which is kind of interesting, because that means there's a reality in the Marvel universe where there was no Thanos to snap anyone out of existence, because he came into our reality to try and get the stones, using the pin particle. So it's kind of like, so in a way, this will blow your mind, but what people don't realise is Tony Stark saved 2 universes. He saved our universe when he went on Iron Man and got rid of Thanos and his army. But because that Thanos left that reality that he came from to our one, that reality hasn't got a Thanos. So if anything, the thing is though, here's the thing though. But then, with Multiverse of Madness, wouldn't that cause an incursion? There are some theories which I haven't looked into yet, where they're like, Doctor Strange didn't cause the incursion with Dormammu. Although, to be fair though, if their idea of an incursion is an impact on reality, they might have nearly caused an incursion with the reality that Thanos no longer exists. Or whereas it's kind of like the actual incursion, because the thing is, even though he didn't spend much time, as it were, in relative terms, in the Dark Dimension when he was fighting Dormammu, he did actually use the Time Stone and piss about. And the thing is, I would agree, and I can understand the possibility, but I would disagree with that theory as well, because don't forget, it wasn't because of his multiversal travel, because they didn't go for the Dark Dimension in Multiverse of Madness. But I think it's because, to be fair, he messed around. There's risks and dangers of using the Time Stone. And when you think about it, the Dark Dimension is a place devoid of time, and he created time within that universe. Therefore, cool. But yeah. So yeah, and I just thought I'd share this article with you. I mean, like I said, I put the link to it in the script below, but it's bloody fun. Oh, hang on. Oh no, what have I, why has it got, how did it get back up there? Alright, so yeah, I mean, but it's really cool, but yeah, I love that, because it's like, Oh, see, look, another article. Time travel theory avoids. Yeah. So, but I want to share it with you because I love this sort of stuff. So let me know what you think about time travel. Do you like it? I mean, the thing is, what would I mean? Considering you couldn't do any major changes in a way, sort of thing. It's like, where would you go forward in time or backwards in time, and which point in time and why? You know what I mean? Again, what I like about the Flash is also interesting. If you had friends, say for example, I went back in time, and went, oh, I messed things up, and I tried to look for my friends or people I knew, their lives may be different than I'm expecting. They might not even live where they do now. They may be different people. I'll be like, you're not so and so, and because even that subtle change, it's like they could be born with a completely different face, different history, all kinds of, like hence the Michael Keaton Batman and the Flash movie. It's fascinating. It's really fascinating stuff. But yeah, it's kind of like the multiverse. But here's the interesting as well, because I suppose is it because they interlace? So that's the thing I haven't figured out. Because someone asked Neil deGrasse Tyson, he goes, do you think dark... Because there's this theory, right, that dark matter we're seeing and dark energy that we're seeing is actually from a parallel universe that's interlaced with ours or interacting with our matter or whatever you want to call it. And they asked, oh, do you think it's that? And Neil deGrasse Tyson was like, I hope it is, because that'd be cool. And I think that'd be cool as well. You know what I mean? But my thinking, what I'm trying to think at the moment now just comes in my head is like, because time travel in a way is like a multiverse. It's like, is that the same multiverse, or is it? I mean, because if just as the amount of stars, I mean, you can't really. It's like people say you can't really picture the size, the scope of the universe is beyond our comprehension. The size and scale of it. But if you just have a guess, like, well, that's fucking huge, right? Just a shitload of with a shitload of galaxy stars on a level we can't imagine. So imagine that as a multiverse and which way that goes. It's interesting, isn't it? But I'm thinking, would they interlace, or is there multiple realities and parallel universes as two separate ideas? Because that'd be interesting. Because also this idea of Ant-Man and Quantumania. There's some theories about parallel worlds living on a quantum level, like a marble, like, you know, Men in Black kind of thing as well. It's like, it's fascinating stuff. Let me know what you think about it in the comment section below. And, you know, let me know what if you could go back in time, where, when, and why. And yeah, and yeah, because I've done some videos on the multiverse idea before, and also various other things, and Mandela effect. That's interesting as well. But I just thought I'd like to share this article with you, and like I said, you can read it properly without me blundering through it, you know, with a link description below. And also wanted to just add my little chestnuts and stuff, and what I've learned from listening to scientists talk about all this sort of stuff. I mean, you know, I'll try my best to explain it. I mean, I really would love like a blackboard or something, you know. So yeah, thanks for watching. Hope you enjoyed the video, and I hope you love this sort of stuff like I did. And if some of you can understand why I got goosebumps and some of that as well, let me know as well, because it's because it's, you know, let me know if you had like a geekgasm as well, because it's like this. I love this sort of stuff. It goes like, ooh. And yes, whilst it's a shame, yeah, I'd love to have Star Trek turn. Well, actually, the phone touchscreen, but I still want my Starship. I'd love to be on a Starship. It'd be awesome. But yeah, but this sort of stuff, like, I really love, and I have a passion for, and an interest in. So yeah, I would like to not just do reactions, I'd like to cover various stuff, and I apologise for any videos where I had a big massive rant, but things just get on top of me, and some things are just stupid, and things just need to be said. And yeah, but anyway, but I do. But apart from that, I mean, that's not ever going to happen again. You know what I mean? It's like, it's just that I just got poked with a proverbial stick. But I want to cover more interesting things. You know, so I want to do reactions, and then cover interesting subjects, sci-fi lore, all kinds of things. You know what I mean? So anyway, like I said, I hope you like this video. Let me know your thoughts and your love about it. If you love science, you know, what you love about it, etc. You know, whatnots, you know what I mean? And yeah, so if you like this video, hit like. If you're new to the channel, then please subscribe because we're going to have you here. Until next time, I'll see you out there in the multiverse. I wonder what would happen. No. Put the time stone down. Although, can I just say though, isn't it a bit? It kind of makes you a bit. It kind of makes you think though. Well, you know, to as TVA, oh, they're just paperweights. I mean, it does actually open up an interesting prospect, doesn't it? Because even though Doctor Strange doesn't have the time stone, he still has the eye, which has powers and that. It's like you could easily someone could nab a time stone from the office drawer of the TVA and give it to him. And go, there you go, mate. You know what I mean? But you know what I mean. Anyhow, hey. Thanks again. Take care. Be well.